Hello, I'm Eric Roch. I'm coming to you from Houston, Texas, talking about real-time integration with LLMs. I've got about 20 years experience in integration, done a lot of real-time integration with more recently AI, so I'm excited to get started and talk about use cases and patterns. So again, Eric Roch. I've spent a lot of time in this event-driven processing, predictive analytics, and more recently, artificial intelligence. And a lot of the integration patterns that I've seen over the years we'll talk about, and I'll give you some advice around setting up such a platform. So here's the agenda. We'll talk about event-driven patterns for Gen AI applications, just different approaches that I've seen over the years. Some of them dealing with things like microservices, event-driven architectures, and so forth. So I work for IWConnect. We're a company been around about 20 years, 350 or so people. We are a global company with offices in Europe and the United States. We got started in the integration space again 20 years ago. Been expanding since then, do a lot with data. Now, of course, AI solutions is a hot topic, and a lot of custom development as well, front end, back end. Of course, that comes into play when you're building these AI applications. So the first pattern I want to talk about really is an integration pattern called RAG, Retrieve-Augmented Generation. It is an AI pattern. There's a set of emerging patterns coming out for Gen AI implementations. This is one of them. This pattern it's actually pretty clever. It involves bringing in your data, your company's data, and integrating it, so to speak, with LLM through kind of the prompting mechanism that it has. So you can see from Aerospike's diagram here, of course, Aerospike's hosting this event, and they have this real-time database that supports vector indexing and so forth. So that will act as a component in this pattern. So the user does the query, that query is embedded, it's queried against a vector database, and kind of a semantic search. It returns your company data information and then includes that into the prompt to the LLM, basically at a very high level. So that way you're able to improve the accuracy of your responses, your LLM's responses for kind of end users in an application. Then provide kind of context rich answers that include your information. So that's the idea of it. We're going to talk about some other patterns that you can use and kind of make this more of a real-time pattern. This is, of course, in this diagram showing a user querying it and getting the response. You can programmatically do that with these integration patterns that we'll be covering. Here's a set of use cases for RAG. I just listed a number of them. I think it is very important to kind of get your use cases right. So consider what is your first project. Maybe you'll do a proof of concept, and then kind of move on to more and more complicated things. The real-time environment that we'll be talking about is fairly complicated. The component architecture is fairly complicated. So it's good to start maybe with something simpler and then evolve into it. So we'll talk about that. Here's some of the examples here that could be real time, or like personalized recommendations in the retail industry. You would really want to respond real time as people are searching through your product catalog with recommendations, and then using an LLM, then you can respond and suggest things, and obviously in a natural language instead of some links and so forth that might not generate the same kind of user response. So As you can see, that this whole RAG pattern requires this integrated data. It requires your data to be in this, if it's unstructured data, in a vector database, so that you can make that matched response between the query, the your data, and then send that to the through the kind of context window to into the LLM through their APIs. So in order to do that programmatically, you need your data to be integrated. You don't want to have to go kind of grab it from a lot of different places, because that would just increase your response time and decrease your reliability and so forth. So you want to build an integrated system that has the data that you need to make these queries. You can leverage a number of tools to do this. Here's some kind of tools that have been around for quite some time. There's even going back further, like Enterprise Service Bus, but I'm starting here with iPaaS technologies or integration platform as a service. You're able to leverage those connectors into your enterprise data, into your enterprise systems, and then make those connections, generate data pipelines that move data around and get it kind of prepped the way you need it, and connect and store it into, for example, a vector database. Then there's transformations and so forth, and there's API management that manages the APIs that might be part of this integration, and certainly like the Open API, Open AI APIs that you're going to need to interface with for the LLM implementation. Here in the diagram to the right, to just give you an example of an iPaaS tool, this iPaaS tool from SnapLogic has connectors, they call them snaps, that you can integrate legacy data, legacy applications. And they also have a product called GenAI Builder that will let you interface to vector databases as well as various LLMs. So it's an interesting tool that you can look at for these kind of applications. So let's talk a little more about real-time integrations, and the products that are in this space have been around quite a long time. The event streaming and event and stream processing products for the Apache projects of Kafka and Flink. Kafka has these brokers that allow you to produce and consume real-time data streams. So it's very appropriate for a use case like this if you want to, one, aggregate your data and then be able to present it to an LLM. This gives you a way to kind of enterprise class way of integrating that. So you'll have data that comes from operational systems, and you want to put that into a vector database so you can do the semantic search. You can do that integration, as well as the integrations on the back end to the LLM itself. So I'll talk about this LogChain framework as well in more detail as I go through this, but it is an open source framework that really abstracts a lot of the constructs that you need to interface with the LLM. I'll again go into it in more detail, but this is kind of part of an application that you can build and leverage this framework to actually interact and kind of have this conversation, if you will, with the LLM between your data. So you could have a component that consumed a Kafka topic and then interfaced with the LLM through this LogChain framework. Okay, so let's move on. So there's here a number of real-time integration patterns, and some of them have been around a long time. Some of the ones kind of toward the bottom were part of the microservices design patterns that have evolved over the years. But the point really here is kind of use proven approaches and patterns when you're doing these integrations. You want the integrations to be reliable and easy to manage over time. So if you build something that, for example, a pipeline that's not monitored that sometimes fails because the data's bad or whatever reason, then that's going to make your overall application unreliable and hard to operate. So you want to implement a pattern approach and a platform approach. So I have a reliable platform as kind of the backbone of building these kind of integrations. I'll look at some of these patterns. The one is change data capture is very popular. So if you've, for example, you want to send an email, a welcome email every time you get a new customer, if that new customer is added into your CRM system like a Salesforce, and that you could watch that database, if you will, for changes, and then when you get a new customer insert, then that really is an event, and based on that event, you could gather data and call the LLM and build kind of an email and natural language, obviously welcoming that customer with some kind of custom data in there. So that's an example. Another important concept here is data products. So a data product is a concept that it's kind of the productizing concept that you're building something that's easily consumable. It's productized, so that has the idea of governance around it. Someone owns that data, they're managing it, they're responsible for what attributes are in that data product. They're responsible for making sure that it's trustworthy and reliable, and that it's easily consumable. It has descriptions, those kind of things. It's cataloged, on and on. So the concept of treating data, for example, like customer data, it's very important information, and then it's very relevant to an application like that when you're conversing with the LLM and the customer. That data needs to be readily available and in very high quality. So that's a concept that's, I think, is important. These other ones are kind of all around event-driven uh, processing. So things like event sourcing and so forth are concepts that if you're building a system like that, it's important to understand, and their sources readily available. If you Google them, you'll find them. So let's dive into this kind of event-driven pattern in more detail. This is from Confluent. Actually, I pulled this from a Confluent blog talking about building an event-driven application with GenAI. I think it's very well done. Confluent offers a hosted managed service for Kafka and Flink and some add-ons that they have, some enterprise class add-ons like connectors and so forth. And they've described this and actually have the code and patterns out there that you can look at. It's very well done. So what they're showing here is building a web application that is event enabled. So when you're doing queries, for example, you're publishing events and then you're getting responses back as an event on a topic. So it creates this distributed architecture that's highly scalable, that that is each component is independently, so the teams themselves scale, the application scale. Although it is a little more complicated, it's kind of more of a microservices type pattern approach to building these applications. So what they're suggesting in this blog is that you have 4 steps here: the data augmentation, which is prepping the data that you're going to use, chunking it, which is creating smaller chunks of the maybe large sets of data, and then creating the embeddings, which are the vectors associated with this data, so you can do the semantic search. So really it's a data prep step. The next is kind of inference, which is matching that data from the semantic search, and then with your data. With matching the prompt information with your data, and then presenting that to the LLM. And then there's a concept of workflows. So you can think of that as like a conversation you're having with an LLM. So the application may ask, the user may ask something, and it generates multiple queries and responses. So there may be additional prompts, there may be additional uh, additional responses from the LLM that you want to pull together in this post-processing step, validate the output, make sure that there's some guardrails around what you're presenting to the user, for example, and then presenting that information to the end user in your web application. You can see there's a lot of components here to build. There's kind of that front end web application. There's kind of multiple back end components here. So it would take a team of people to build this, and kind of experts in messaging and then front end development, back end kind of microservices style development for these back end services. So let's look at LogChain in some more detail, because it's a very interesting and clever implementation. It gives you a lot of these abstractions that you need to interface with the LLM. So I like to just look at the core components here. It kind of abstracts the APIs for the LLMs, so it gives you an abstraction layer there, so you could potentially switch your LLMs out. Maybe you want to go to a small model or a large model, depending on the use case, kind of using the same framework. There's also prompt templates. So as you're having this kind of conversation with the LLM programmatically, you can build a template that is going to be the prompt to the prompt that you would normally kind of type into the context window. That prompt you build as a template, and then you interface with that template. You can put variables in there and so forth. So it programmatically gives you a way to create this template to get a good response from the LLM. The next thing is agents. So these agents have the ability to do things like query into Google, do a Google search, do a Wikipedia search, those kind of things, pull in external information, combine it with your internal information, and have this conversation with LLM they call a chain. So you chain these conversations together along with these agents to generate the information you want from the LLM. Again, there's retrievals, so you again want to transform, store, search information. It has the ability to remember the conversation, so you can turn on a memory, the variable to turn on memory, and it will remember that whole conversation, so you can refer back to it. And then it's got the whole kind of operational things that you would want, monitoring and so forth. So it gives you that framework to do this implementation. And then when you're embedding and reading, for example, or consuming a topic from Kafka, and then using this framework, then that's how you go about building this real-time application. So let's recap. I mean, there's these systems like this. If you want something that's highly scalable, that's reliable, does take a set of components to build it. So there's various skills. So you need to think about what that team's going to look like. I like to call it the operating model. So who's going to do what? What are the roles and responsibility, from building, for example, the front end to building the back end components, to managing the messaging environment, the integration platform if one's in play, the operational aspects of it, who's going to monitor it, how is it going to be monitored, what tools are going to be monitored there. So there is a kind of an operating model that you need to set up around a product like this. So then the idea that you're pulling this data together and operationalizing it, with you will. So if you will, then there's the concept of this data products for your critical data, like customer data or healthcare patient data, something like that. You would want to treat that data as a product, so you don't have to add, the LLMs are not the quickest to respond, so you don't want to have to grab a lot of data from different places. That would just add to that response time. So again, you want this unified operating model, kind of a platform approach for data integration to support an application like this. So again, you want to define your operating model. You want to adopt these event-driven patterns. Don't kind of recreate the wheel or reinvent the wheel. You want to leverage platforms and patterns that are well established, that would be that a common thing. You can find examples of how they're implemented and so forth in products and so on. Consider also the long-term cost, this is the data engineering cost, and the operational concerns. So you don't want something to build an integration that's fragile, that's blowing up, and then your data is not current, and then the whole kind of premise of having an intelligent application just goes down the tubes. Finally, it's good to partner with technology companies and consulting companies that's done this before. At IWConnect, we have done this. We've been doing integration for 20 years. So we know how to build applications like this. We know how to do the strategy work, the integration work, the front end development, all of those pieces. If you need any help, reach out. So here's the easiest way to contact me is on LinkedIn. So Eric Roch, just look for me on LinkedIn Connect, and we could have a conversation and dive into this in a lot more detail. Thank you for time.